Howdy, calculates. So in this chapter, we're going to look at log and exponential functions and learn how to do both derivatives and antiderivatives on them. So if I have natural log defined as the accumulation function from 1 to x of 1 over t, and I want to take the derivative of that, so we'll let y actually be this natural log of x, and I want to take the derivative, so I would have y prime. And remember, I'm taking the derivative of this side, so d dx would fit right in there. And when I do that, remember it cancels out the integral symbol, and then I put the variable in and take the derivative of it, but the derivative of x is just 1, so I'll end up with 1 over x. So let's recap that again. What we're saying then, by definition, is when y equals natural log of x, that y prime is equal to 1 over x. And I'd like to look at a quick picture of it. It's always hard for me to think my brain in terms of any type of logarithm, but I can rewrite this. Remember, it's a teeny tiny base e on that natural log. So there's a little tiny e down there. And I'm going to put it back into exponential form. So it's going to look like e to the y equals x. And so any exponential has a y-intercept at 0, 1. So if y is 0, in this case, x will be 1. And we're going to see how that makes sense in just a little bit, because typically I have y equals. So I'm going to think of y equals e to the x, because these two equations are inverses of each other, meaning the x's and y's trade places, right? And I know how to graph this. It'll have a y-intercept at 1, because when x is 0, y is 1. And then if I plug in x equals 1, I'll get e, which is 2.7 something. Remember, it's irrational. I actually don't keep that number memorized. And so forth. And so what's happening for e to the x, we'll graph this one in green since I wrote it in green over there, is that it looks like this. And remember, inverses are nothing more than mirror images across the line y equals x. And so now it'll start to make sense. Oh, so if I take the mirror image, remember over here on the left, I was touching at 0, 1. So when I flip over y equals x, I should be touching at 1, 0. Oh, that's right, I already figured that out in the table. And then it's going to go this way. Now, on the green version, I get an asymptote at the y-axis. And on the yellow version, I get an asymptote at the y-axis. And keep in mind that what's in yellow is the exact same thing as my original equation. It just looks a little bit different, but these are the exact same thing. Just one is in log form and the other is in exponential form. So this is my graph of natural log of x. And that is going to be helpful.